So hi, let me introduce myself. I am Ashish from Learnbay. So we're going to discuss about Python today, and tomorrow we're going to have a case study on stock price. Okay, guys, let's start. So today we're going to discuss about Python. If you have any doubt, then you can ask me and we'll discuss. So first of all, guys, Python is a high-level language. What is the meaning of high-level language? Any language, that is written in the human understandable form, then you can call it as the high-level language. So there are different examples of a high-level language, like you can say, C, C++, Java, all these are the examples of high-level languages. The same way, Python is a high-level language. Now, if you see, like nowadays, you might have seen Python is very famous. Yes or no? And when it comes to data science, so like it is the, like that everybody is learning Python. So the thing is, why are we learning Python? That question, arise in mind, like why Python for data scientist or data analyst? Anyone would like to say something about this? Why Python?
Because it has many modules that like pandas and
oh, that is great. Great. So the reason is, Python, provides rich source of libraries. You call it libraries or packages, right? Rich source of libraries. So you don't have to worry about the logic and all. You can just, you have to know, a particular library, how to import a library and how to use a particular function. If you know that, then your task is done. So if I talk about, different source, different libraries, so we have, like we have NumPy. NumPy that we use to, perform the numerical computations on a very large data. It is used for numerical computations, like metric computations and all. Then we have, pandas. So pandas is used for data manipulation, to work upon the, tabular data. We use pandas like we do in Excel. So that for that we use pandas. Then we have matplotlib and seaborn. So matplotlib is used for visualization. Then we have seaborn. So seaborn is also used for visualization. And apart from that, we have different more libraries to work upon statistics, more advanced operations in statistics and all. So that is why Python is very famous. If you know a bit of these libraries, you can do advanced computations with less code. Okay, that is the beauty. You can do the advanced computations with the less code. NumPy, pandas, matplotlib, and seaborn. Apart from that, we have sklearn for algorithms and all, and for to work upon the text data. We have NLTK, SciPy, and so many are there. So what I'm trying to convey is we have rich source of library. That is why Python has been famous. Apart from that, Python is easy to learn. So anybody like who does not have any prior experience to coding, they can easily learn Python. Is it clear, my friends? Why are we learning Python, or why Python has been very famous in, when it comes to data science or data analyst? It is not only like data science or data analyst. If you know Python, like you can, it's a general purpose language. It is not like you can only work in data analysis or data scientist field. You can go into web development, app development, and different things you can do, game development and all. So if you know Python and you want to move any of the fields, then you can easily do that. So it's a general purpose language and you can do a lot. If you know Python, all you need to know is the particular libraries related to a particular field. Like for web development, you are going to, learn a different set of libraries. For, data analysis or data scientists, you have to learn a different set of libraries, and that's it. So if you want to work on data, then you can use this. In that case, also you can use Python. Clear? So today we are going to have an introduction of Python. How do we, write the code and all. So, okay. Yes, please. So first of all, let's talk about the data type to work upon in Python. First, what is a data type? So anybody would like to say something about data type?
It shows that any data is a type of a text or a number or a decimal
Yes, yes,
data
yes.
type such as that.
Yes, great, great. So if you see, guys, we can have a any kind of data. Data may be anything, yes or no? So before data, before data type, we should know what is the data. So if I say what is the data, data may be anything. Agree my point? Data may be anything. Anything means it may be a number. It may be, it may be text. It may be images. It may be audios. Okay. It may be videos or anything. Data may be anything. There may be many more categories. So when we work upon different kind of data, so to store in the memory, we have different kind of memory requirement is there, right? So for what do we do? What utility we have been provided with is the data type. Data type is nothing but it is a type identifier that tells on which type of data we are working. Okay, it is a type identifier of the data. So in Python, we have two types of data types. Okay, if I talk about the types of data types, we have two types. Number one, we have the basic data types. And the second one, we have the derived data types. So let's discuss first of all the basic data types, guys. So knowledge of data types is very important when we work upon in any language. It is not like Python, but in any language if you want to work in. So the knowledge of data type is very important. Okay. It is not basis, it is basic data types, guys. So in basic data types, first of all, we have integer. In integer, we have, any number, whether it is positive or negative, without a decimal point. Then we have float. In float, any number, whether it is positive or whether it is negative, with a decimal point. It's just a category. Okay, if any number without a decimal point, it is treated as integer. If any number with a decimal point, it is known as it is treated as float. Okay, then we have string. String is anything. It may be anything kept inside the quotation mark. Like we have single quotation, then we have double quotation, then we have triple quotation, and then we have triple quotation 3 times. So anything if we keep in this, that is known as a string. Then apart from that, we have complex. If we in complex, if I talk about complex, so any number or any number in the form of a plus bj. So it is known as complex. So we will see some examples of them. Then we have Boolean. In Boolean, we have true or false. So two values, true or false, and then we have none type. In none type, we have none. So these are the basic data types. Let's discuss what is the meaning of that, like integer, float, string, complex, Boolean, and none type. First of all, let's say we are talking about the integer types. So integer is what?
Sir.
Yes, please.
Yeah, sir. Apologies for disturbing. Sir, will you be touching upon the analysis part? I mean, the stock price prediction part today?
No. That is we are going to have
Okay.
tomorrow. Today I am going to give Python introduction.
Okay. Yeah, thank you.
Or
Sir.
different
Thank you.
libraries. Then you look Python like how
Mhm.
to work in NumPy, Pandas, Seaborn, and Matplotlib. Okay.
Yeah.
So
Sure,
that
sure. Thank
tomorrow
you.
you can understand how to plot a particular graph, or how to read the data from the file and all.
Mhm.
Okay.
Okay, sir. Okay. Thank you. Yeah.
You're welcome. You're welcome. So integer, integer is what? For example, I say a equal to 10. So now 10 is what? 10 is the value that I am storing in a variable a. Now you tell me 10 is what? 10 is a number. So if 10 is a number, it may be, integer, or it may be float. So we have the type function that tells us the type of any data. So if I say a print a, it is printing 10. Okay. And if I check the type of a, so it is giving us class int. It means it is of integer type. Int means it is of integer type. So any value that is, with any number without a decimal point is an integer. Understood? Now the same way, if I say, a equal to 0, and I say, print a and type of a. So again, 0 is also an integer value. If I say a equal to -10, and I say print a and type of a, so it is again integer. So can we say, like, if we have, any value that is what? Any number, whether it is positive, negative, or 0, it is an integer value, yes or no? So any number, positive, negative, or 0, will be treated as integer. Now let's say if I say a equal to, let's say 2.5, and I say print a and type of a. So this is the number with a decimal point. If I execute, you say like it is a float type. So any number, if it has a decimal point, it will be treated as float. It doesn't matter whether it is 0 or negative or positive. It says, if I say 0.0, 0.0, and if I say print a and type of a, it is again float. If I take a negative number and I say a equal to, minus 5.5, and if I say print a and type of a, it is again float. Fine. So can we say any number without a decimal point is integer? Any number with a decimal point is float? Agree my point, guys? So these two we have seen, like float and integer, integer and float data types. Now this string, let's say I am saying a equal to, and I say Python. Fine. And if I say print a and type of a, so string you can say text. It is class str. Str stands for string. So anything that we keep in the quotation mark is known as a string. If I make it in the double quotation mark, let's say I say a equal to, not the single but double quotation, and I say Python, and I say print a and type of a, it is again string. It is again string. If I put it in the triple quotation mark like this, and I say Python, and I say print a and type of a, it is again string. So what is the difference between single, double, and triple quotation? For example, the output that I want like this. The output should be like this. Python's class. In the output, I want this, single quotation mark. And I say a equal to, and I say, like this. Python's class. So if you see here, if I print a and type of a, it is going to throw me an error. It is giving me invalid syntax. Why it is giving me invalid syntax? The opening is the single quotation and it ends here. So interpreter understands, okay, the string ends here. Then again, we have some values. It is not, getting like what is happening further. Are you getting my point? So this is the opening string. Okay. And start of this string, this is the end of this string. And further, it is not understanding what is happening. So if we have single quotation mark as the part of the string, then we can cover the string in the double quotation mark. If I do like this, can you say we are getting the output Python's class? Fine. So if single quotation mark is the part of the string, we can cover the string in the double quotation mark. Now, for example, the output that I want is like this. Output should be, like this. This is Python class. So in the output, Python should be covered in the double quotation mark. Now, if I say A equal to, and I say this is, and then again I say, you know, Python, and I say class. And again I say print A. It is going to throw me an error again. Why? This is the start of the string, this is the end of the string. Then it is not understanding what is the meaning of this Python word here. Fine. So if we have double quotation marks as the part of the string, then we can cover the string in the single quotation mark. If I do like this in the single quotation mark and then execute, we are getting the output. Fine. So I hope you have understood like what is the difference between single and double quotation marks. So if I have the single quotation mark as the part of the string, I can cover the string in double quotation mark and vice versa. Now, what is the use of triple quotation mark? For example, I say, I have a multi-line string. So I say this is, this is Python webinar. And then I go to the new line. Okay. So it is like, stock price analysis. Stock price analysis we're gonna do. Fine. Then again, I say, we are from Learnbay, something like that. So if I have a multi-line string, if I say print A and type of A, so it is giving me the error. Why? So when we have multi-line string, so single quotation mark is not going to, understand what is happening. It does not recognize the new line character. So what we do, if we have a multi-line string, we cover that string in the triple quotation mark. That's it. Can you see? We are having the triple quotation marks now. I execute and we are getting the output like this. So if we have multi-line string, we cover it in the triple quotation mark. It can be single, triple quotation or double triple quotation. So this is the, string type. First of all, we have integer. Then we have, float. And here we have discussed the string values. String. Now we have the Boolean, or let's say the complex. If I talk about the complex, if I say A equal to 10 plus 20j, let's say. So anything in the form of like this, 10 plus 20j, A plus bj, it is treated as a complex value. It is a complex value. So when we have A plus bj, so 10 will be the real number and 20 will be the imaginary number. Okay, so 10 is known as the real number and 20 is known as the imaginary number. Fine. So it is a complex value. It can be, if you have a float value, it doesn't matter. For example, if I say, 2.5 plus 0.2j, something like this. So it will be still a complex value. It is still a complex value. Fine. So this is complex. So this is used mainly, by in the advanced mathematics when we want to work upon the real and imaginary numbers. Now we have the bool data type. If we talk about the Boolean, only true and false are known as the bool. If we write true, so T should be capital. Okay, it is a keyword in Python. So true we write like this. And if I say print A and type of A, sorry, my bad. So it is the Boolean. Can you see it is a Boolean type? Now, if I say A equal to false, so F should be capital and then I say print A and type of A. So it is a Boolean type. Fine. Now we have the none type. If you talk about none type, so none is the none type. If I say A equal to none, so it represents the null values or the missing values. Okay. And if I say print A and type of A, so it is of none type. Yeah. So these are the basic data types that we usually work upon. So integer, float, string are the main. Okay. And this Boolean.
Kajal?
Fine. Now the most important thing that Python provides is the derived data types, guys. So these are more important. So derived data types are kind of data structures that we use to store multiple values, at a time. If you want to store multiple values at a time, then you can use derived data types. In derived data types, first of all, we have a list. Okay, so what is a list? Anything kept inside the square brackets is known as a list.
लिंक ऐक ना तो काय म्हणजे
Fine.
स्टॉक प्राइस अनालिसिस युजिंग पायथन सांगते काय
Pardon?
स्टॉक प्राइस कशी अनालाइज करायची ना ते शिकून घे.
I'm not able to understand what you're saying. Do you have any question, please? Hello. If you have any question, you can ask me. Okay. So anything we kept inside the square brackets is known as a list. Yeah, Karthike, if you want to work upon the date time, we do use that in NumPy and Pandas, not in core Python. Okay. So if we use NumPy and Pandas libraries, there we can work upon the date time and object data type. Understood? So I'm going to come on that. Okay, we are going to discuss the NumPy and Pandas also. Fine. In core Python, we don't have date time or like we have module date time if you want to work upon the date time data. But generally we do that in NumPy and Pandas if we want to work upon the date time and object data. Now the list, anything kept inside the square bracket is known as a list, and it can store heterogeneous elements. Heterogeneous values. So let's say, for example, I say a equal to inside the square brackets, and I say 1, 2, 3, 4, 5. 5 values I have given, and if I say print a and type of a, so we are getting 1, 2, 3, 4, 5, and it's a list, right? So it can store the heterogeneous elements. For example, I say 5, it's an integer value. Then I say 2.5, it's a float value. Then I am saying, like Python, it's a string value. Fine. Then I say true, it's a Boolean value. Then I say none, it's a what? It's a none type. Fine. Then I say 10 plus 20j, it's a complex value. And if I say print a and type of a, so it is again a list. Fine. With the help of indexes, so list uses the indexing method. So indexes always start from 0, like this is 0, 1, 2, 3, 4, 5. If you want to access any particular element, if I want to get the first element, you can say 0 and I am getting 5. If I want to get Python, so 0, 1, 2. So if I say A2 and I am getting Python. So this way we can access the values, from a list. So it can contain the heterogeneous elements. Okay. And it uses the indexing method. Next, we have the tuple. So in tuple, anything kept inside the parenthesis is known as a tuple. Let's say I say a equal to, and here I say 1, 2, 3, 4, 5, and I say print a and type of a. It's a tuple. It's a tuple. It can also store the heterogeneous elements. For example, I say a equal to, and here I say, let's say true, then I say Python, then I pass a list here, let's say 1, 2, 3, something like that, and then I say 50 or something. Again I print a and type of a, so it's a tuple. Again it's a tuple. So it can also store the heterogeneous elements. It also uses the indexing method. The same way, if I want to access the first element, I can pass the 0 index. The index of the first element is always 0. If I want to get the third element, so third element, the index of the third element will be 2, and I am getting at the third, it is a what? It is a list. So list and tuple, both are almost the same. There is only one difference. In list, after definition, after defining the list, we can change the particular element, but in tuple, we cannot do that. In tuple, we cannot do that. So list is mutable and tuple is immutable. What is the meaning of mutable? We can modify the values. We can. What is the meaning of immutable? We cannot modify the values. Fine. So this is mutability and immutability. For example, I have a list and I am saying 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I am printing list. So this is a list because it is in the square brackets. Now what I do, I say LST of 0. I want to change the element. Instead of 1, I make it 100. And if I say print LST, can you see the first element is 100 now? Can we say like we can change the values in a list? Yes, Roshan, I will tell you. Yes. Can we say in list we can change the values? Now the same, let's try with tuple. I say t equal to, so let me go to the new cell. For example, I say tuple, I take a tuple and I'm saying 1, 2, 3, 4, 5. And I say, print tuple. So it's a tuple because it is in the parenthesis, covered in the parenthesis. Now I say, tuple of 0, it is 1. I want to change it to 100 and I say 100. And you say it is giving me the type error. Tuple object does not support item assignment. Item assignment is the equal to operator. It means once we define the tuple, we cannot change the element. Once it is defined, it is defined. Understood? But in list, anytime we can change the elements. So that is the only difference in list and tuple we have. Fine. So list is widely used. When we want to change the values at any time, we use the list method rather than tuple. Okay. Tuple is used in generator operations. Okay. Like generator function to create an iterator object. Yes, Roshan. That is a separate topic. Okay. So tuple we can use for memory efficient operations. Let me show you. Let's say I create a list. With the help of loop, and I say 1, 2, 3, 4, 5. So it is going to create a list of 1 lakh elements, 1 lakh values from 0 to 99,999. Okay, and if I show you the size, what is it taking? How much bytes it is taking? 8,24,456. Okay, how this much of bytes it is taking. Now the same I create with the help of tuple. And I say I for I in range. And I say 1, 2, 3, 4, 5. Fine. And then I use the same, like I check the size, how much size it is taking. It is taking only 112 bytes. Can you see there is a huge difference in the memory consumption? It is a list. It is a tuple. I am using a comprehension method to create a list of 1 lakh numbers and tuple comprehension to create a tuple of 1 lakh numbers. Okay. So this is the generator object. When we use the tuple comprehension, what it does, it is going to create the numbers when we ask for. Otherwise, it is not going to create the numbers. That is why it is consuming less memory. Whereas when we define the list comprehension, it is going to create all the numbers at one go. Okay. I'm not printing it. If I print, like my kernel will crash. Okay. It will take a lot of space. So it is going to create all the numbers, and that is why it is going to consume the memory, all the memory. Yes, Roshan, is it making some sense now? So tuple we can use for memory efficient operation, or like you want to provide the data that you want, it should not be changed. Some utility you want, like it should not be changed. In that case, you can use tuple rather than list. Understood? So this is list and tuple. Next we have the set. Anything kept inside the this curly braces is known as a set. Is known as a set. So what is the utility of set? It does not contain the repetitions. It does not allow duplicate values. It does not allow duplicate values. For example, I say 1, 2, 3, 4, 5. Any number you can pass, and if I say print A and type of A, so you can say it's a set. It's a set. Now I pass some repetitions. For example, I am saying, are we having some repetitions here? Yes or no? Some values, those are being repeated. If I print this set, you can say it is taking the unique values only. It is not taking the repetitions. Okay. So that is the utility of set. It does not take the duplicate values. It only allows the unique values. Fine. Now we have a dictionary. So anything, it is a very, very important, data structure in Python. Anything kept inside the curly braces, okay, in the form of key colon value is known as a dictionary. In the curly braces, if we directly pass some elements separated by a comma, then that is a set. But if we have anything in the curly braces in the form of key colon value, then it is known as a dictionary. Okay. So for example, I say my dict equal to, and I say, for example, I want to store, like, let's say, name, and name has been assigned to, let's say, Roshan. Fine. Then let's say I have code, and code has been assigned to, like, let's say 105. Then let's say, address is, let's say Noida. And then, company, let's say TCS. So this is a dictionary. If you see here, we have the key. This is known as the key colon, and this key has been mapped to this particular value, Roshan. This key is the code, and this has been, is matched up to, this value, this 105, something like this. Okay. Now let's say if I say one more key, let's say salary, and you say, like, say 95K. Okay, 95,000. If I say print my dict and type of my dict, execute. So we are getting a dictionary, and the type is dict. Dict stands for dictionary. It is the keyword for dictionary is dict. Fine. Now what is the benefit of it? For example, I want to get the name. So what can I do? I can pass the name, any key, as the index. I want to say name. So name is Roshan. I want to know what is the code. So if I say code, we are getting 105. For example, I want to know what is the address. We are getting Noida. Now what I want to know, like, what is the salary. We are getting 95,000. So that is, if we have a multi-layered data structure, want to store the value, like employee data or something like that, then you can use a dictionary in that case. Fine. So if you want to extract the keys, we have keys function, guys. If I say dot keys, it is going to give you all the keys. So in dictionary, we have keys name, code, address, company, and salary. If we want to get the values, we can say mydic.values. And we are getting all the values like Roshan 105, Noida, TCS, and 95,000. These are the values. So these are the basic and Terra data types in Python, guys. I hope it is making some sense. Any doubts till now, you can ask me, please. Shall we move ahead then? Now we are going to discuss the libraries now. A bit overview of the libraries. So let's discuss a bit about the NumPy. NumPy stands for numerical Python, guys. NumPy stands for numerical Python. Any library, when we use any library, okay, to work in NumPy, we have to import it first. Any library, if we want to use that particular library, first of all, we have to import. So what do we do? Okay, NumPy provides a data structure known as arrays. So okay, so if we want to work upon the arrays, then we use NumPy. So now the question is, what is array? And what is the use of it? So array is a collection of, it is the collection of homogeneous elements. Fine. And why do we use arrays? So arrays are faster than list. Okay, so arrays are faster than list, and in list we can store the heterogeneous means of different type of elements or different data types. If you see here in the list, we could store different type of values. Yeah, like one is integer, float, string, and all. Okay, but in arrays we can only store the homogeneous means of same type, but array is faster than the list. Apart from that, okay, we can, with the help of NumPy array, we can compute the advanced sophisticated numerical calculations on the very large data. Okay, on the very large data. So first of all, how to import NumPy? How to import NumPy? So we say import NumPy. So this is, so now any operation, any function that we want to use, we have to say NumPy dot. Okay, and then for example, I want to create an array. We have array function, and here we can pass a list or something for which we want to create an array. For example, I am passing these 9 values. Okay, and if I execute, so this is an array. Fine. So any function, if I want to use from NumPy library, every time I have to write NumPy dot, and I can access any function defined in this particular library. So NumPy, it takes time, like to write NumPy every time. So to make it easy, what we can do, we can give a name like as NP. NP means like we have given some name. You can give any name as per your choice. You can say N or whatever. Okay, so import NumPy as NP. When we do like this, so we don't have to write NumPy every time. We can just write NP, and if I'm executing, I'm getting the same amount. Understood? So in NumPy is the library that we use to work upon arrays. An array is a function that we use to create an array. Fine. So this is an array. If I store in a variable, let's say array equal to variable name, you can take anything. And if I say print array and type of array, so you can say it's an array. It looks like a list, but it is not a list, guys. It is an array, and it is saying the class numpy.nd array. N means n-dimensional array. Nd array means n-dimensional array. Understood? And if you want to check the type of the elements, so you can say array.dtype attribute, and it is telling you integer 32. So all the values are of integer type. All the values are of integer types. Understood? Please tell me if it is making sense. Fine. So different attributes on array everyone. So first of all, I am creating an array, np.array. And I am passing, let's say, this is the 9 elements I have. So we can say array.d type. It is going to tell us the type. Then we can say array.size. It is going to tell us the size. Size means number of elements. So 9 elements we have. Then we have array.ending. It is going to tell like what is the dimension of the array. So it is a one-dimensional array. It is a one-dimensional array. Now, what is a two-dimensional array? Let's say the reshaping of an array. Reshaping of an array. So I have this array. How many elements it has? It has 9 elements. Now I want to reshape it in a 3x3 array. 3x3 array means 3 rows and 3 columns. It should look like a matrix. Okay. So to work upon matrices, we use arrays. Okay. And I want to look like, I want it to look like a matrix. So what can I do? I can use the reshape method, reshape function, and I can pass the dimension. I want 3 rows and 3 columns. Execute. And if I say array, can you say it is a what? It looks like a matrix. 3 rows and 3 columns. And remember, 3 multiplied by 3 is what? 9. So what is the product of the shape? The number of elements you have should be the same. If 3 by 3 is 9, here we should have 9 elements. If I increase one element, let's say 10, then it is going to throw an error. That is the value error, like it cannot reshape 10 elements into 3 by 3 shape. Understood? So it has to be like this. Fine. So now if I say array.ending, it will be a two-dimensional array. Two-dimension means rows and columns. When we have something in the form of rows and columns, it is treated as a two-dimensional array. Fine, guys. Now, creating different kind of arrays. So different functions we have to create different kind of arrays. First of all, we have np.arrange function. In arrange function, what do we do? First of all, we pass the start, then stop, and then step 3 values. 3 values we pass. So it is going to create an array of the values in a particular range. Okay, particular range. For example, I want to create an array. Create an array of the natural numbers from let's say 1 to 25. 1 to 25. Okay. Remember one thing, that stop value is excluded. Excluded means if the stop is 25, it is going to give us the values up to 24. If the stop value is 10, it is going to give us the values up to 9, like that. So what can we do, guys? I can say np.arrange function. So what is the start value? That is 1. What is the stop value? If we want up to 25, stop value should be 1 extra. And if we say we are getting an array of 25 values, 1 to 25. Fine. Now, if I say create an array of even numbers between 10 and 50. I want to create an array of even numbers between 10 and 50. Then what can we do? We can say np.arrange. And I say the start index is 10, stop index is, I have to take 1 extra, let's say 51. And now if you say the even numbers, so if 10 is the even, then next even number would be 12, yes or no? Then next, next even number would be 14. Then next would be 16. So step size we can pass to. It means it is going to skip one value in between. It is going to skip one value in between. You can say like 10, 12, 14, 16, 18 up to 50. We are getting all the even numbers. Fine. If I say array equal to, and if I say this, this is the array, and if I say array dot let's say size, so we have 21 elements. Now I want to reshape this array 21 elements like 7 rows and 3 columns or 3 rows and 7 columns. So what can I do? I can say reshape it. Let's say 3 rows and 7 columns I want. You can see I have reshaped it into 3 rows and 7 columns. Fine. So this is the arrange function that we use to create the values like this. Now we have the random we can create the array of random values. Before that, let's say this np.zeros function we have. So np.zeros, it creates the array of zeros. Array where all the elements are zeros. So how do we say np.zeros? And here we take a, we have to pass a tuple. Tuple means the square brackets, and we can pass the shape. Shape like, let's say 3 rows and 3 columns I want. We are getting 3 rows and 3 columns where all the values are zeros. And if you say the type is float, why float? By default, it gives the float value. We are getting the decimal point. If you don't want this decimal point, you can change the type to integer like this. Now all the values are integer. Fine. If I make it 3 by 4, so 3 rows and 4 columns you're gonna get. If I say 5 by 5, so 5 rows and 5 columns we're gonna get like this. So this way you can create array of zeros like this. Now you want all the elements to be 50, you can say plus 50, and you every element will be 50. That is why arrays are faster in calculation. I'm saying plus 50 and plus 50 has been added to each element one by one. We don't have to apply loop or something. Understood? If I want all the elements to be 50.7, you can do that, and all the elements are 50.7 like this. Please tell me if it is making sense. Now we have np.zeros, np.ones. So it is similar to this, what to call np.zeros. So what it does, it returns an array where all the values are 1. So we can say np.ones. Here we have to pass a tuple, and we can give the shape. Let's say 4, 5 and execute. 4 rows and 5 columns we have got where all the values are ones. By default, it gives the float values. If you don't want the float values, you can change the type to integer like this. And we are getting all the values as integer. Now, if you want all the values to be 5, you can say multiply by 5 and all the values will be 5. Yes. Fine. So this is like np.ones, np.zeros. Then we have, np.I. This is used to create an identity matrix. What is the identity matrix? Identity matrix where the diagonal are 1 and rest of the values are 0. the diagonals are ones and rest of the values are zeros. So that is known as the identity matrix. So we can say np dot I, and here I say 3, 3. So we have 3 by 3 matrix we have got, where you can say all the diagonals are 1 and rest of the values are zeros. If I say, let's say 5 by 5, so again it is an identity matrix where all the elements are diagonal elements are 1, rest of the elements are 0. You want to change the type, you can say type equal to int and all the values will be integer. Like that. Okay, so this way we can create a different type of arrays. Then we can create array of random values. So in to create the array of random values, we have to use random module. We have np dot random dot rand, and here we pass the shape. np is the library, numpy library, random is the module inside the numpy library, and rand is the function that we use to create the array of random values. Okay, it creates the array of the given shape of random values between 0 and 1. It creates an array of the random values between 0 and 1. For example, I say np dot random dot rand, and this shape is like say 3 by 3 and execute. So it has created a 3 by 3 array where we are getting the random values. Automatically, randomly it has taken the values. So if we want to create an array of random values, then we can use np dot random dot rand. Okay, and we can pass the shape. If I say, let's say 3 by 5, so 3 rows and 5 columns we're gonna get of the random values always between 0 to 1. Now, if we don't want the float values, we want the integer values, then we can use np dot random dot rand int function, and here we can pass the start, comma, stop, and comma the number of values we want. Number of values we want. So for example, I say np dot random dot rand int. Between 1 to 50, I want 10 random values. So between 1 to 50, 10 random values it is giving me. Okay. Let's say 1 to 5, I want 10 random values. It is going to give me 1 to 5, 10 random values. So because 1 to 5, we cannot have unique values, unique integer values. We are getting the repetitions. So randomly it is giving us the values. Let's say between 10 to 50, I want, let's say 25 random values. It is giving us 25 random values. If you want it to look like a matrix, then you can reshape it, and you can say reshape, and you can select 5, 5. It's a 5 by 5 matrix of random values we have got. So to work upon the arrays, we use the numpy module. Is it making some sense, guys? Please tell me. So we can create different kind of arrays with the help of numpy. So what is the use of numpy in when it comes to the data analysis or data science? See, sometimes what do we need to do? We need to create a column or row, of different numbers. So with the help of NumPy, we can easily do. As a data scientist, sometimes what do we need? We need to, check the accuracy of our model on different values. And then what we can do? We can create the arrays of different numbers, different type of numbers, and we can feed that to our model to check the accuracy. We can do that. Fine. Is it making some sense? Shall we move ahead? NumPy is widely used in space research, etc. Because there, calculation is very important, accuracy is very important, and sometimes they need to work upon the very large, numerical data or numerical numbers. So in that case, they use NumPy or such fields or similar areas. You can see. What is the other use of NumPy? Data may be anything. Okay, any kind of data can be converted into arrays of numbers, and then we can manipulate that data with the help of NumPy. Okay, so that is the use of NumPy mainly. Fine. Now next we have the pandas. That is very important library. Okay, so pandas stands for panel data, guys. Panel data means tabular data. When we have the data in the table format, okay, it is used to work upon tabular data as we do in Excel. Fine. So to use pandas, to work in pandas, first we have to import. So how to import? We can say import pandas. Then again, any function, if I want to access from pandas, every time I have to write pandas. So what we do, we can give a name, let's say PD. So now I can access any function related to pandas with the help of PD. I don't have to write pandas and pandas every time. Okay. Now we can check the version of pandas. So we can say PD dot underscore version underscore. So this is the pandas version. The same way you can check the NumPy version also, NumPy dot underscore version underscore, and you are getting the NumPy version. Okay, so different versions are available. So if you want to check, you can check the version also. So in pandas, we have we work upon two type of objects. Number one is the series object. And number two is the data frames. So let's talk about the series. What is a series? It is like a 1D array structure. It can be treated as a single column of a table in Excel sheet we have. If you say in Excel sheet, we can have different kind of columns. Okay, different columns. So single column can be treated as a series object. Okay, now how to create a series? How to create a series? So we can use pd.series function, and here we can pass a list, we can pass a tuple, or we can pass a dictionary to create a series. Fine. So let's create a series. Let's say I say pd.series. We can pass array also. Okay. Let's say I have an array. I say array equal to np dot arrange. Okay. Or let's say np dot random. dot rand in, and between let's say 10 to 50, I want 10 values. Okay. If I say array, this is the array we have. Now I want to convert it into a series object. I will say pt.series, and I can pass this array. When I say series, so it has, if you see, it has created a series. So these are the values we are getting 11, 29, 31 that has been created by an array, and on the left side we are getting the indexes. Let's say I give a name, let's say ser equal to, and I say series. So we are getting the series. Okay, here we have the indexes, here we have the values. If I want to access a particular element, I can pass as the index like 0. At the 0th index we have one element. If I say 5, at the 5th index we have 16 elements. Understood? So this is the series object. It is a single column, you can say, in the in an Excel sheet or in a table, we can say. Fine. So this way we can create a series of different types, different values. We can sort a series also. So we can say ser dot so if you can see, like it has sorted in the ascending order. Yes or no? The series has been sorted in the ascending order. If you don't want the ascending order, you want in the descending order, you can say ascending equal to false, and you are going to get in the descending order. So this way you can do different operations on a series object. So with the help of array, we have created a series. Yeah, series can be anything, Sujita. Like it doesn't matter whether we have homogeneous or heterogeneous elements. If we have heterogeneous elements, then the type will be object in that case. Okay, the type will be object. Let's say this is the series. Okay, this is the series we have, and let's say the 5th element, I make it I make it A, and if I say series, can you say the one element is A? Earlier the type was integer, the type is object now. So here we had the homogeneous elements, the elements of same type, but here we have the different type of elements now. Right. So when we have heterogeneous elements, so the type will be object. Understood? Yes. Let's say the very first value, you want to make it a float value, you can do that. Just make it 4.5, let's say, and execute. And if I say series, the first value is 4.5, one value is string, rest of the values are integer, and the type is object. Any doubt? Yes, Sujita, is it clear? So it can hold the heterogeneous elements also. We can create a series from a dictionary also. And let's say I have a dictionary D equal to, okay, and I have the values like let's create a data frame. Let me show you the data frame first. So data frame is what? It is like a 2D data structure, okay, 2D array structure. 2D array structure, okay. It can be treated. It can be treated as a table, complete table in Excel sheet. Okay. As we have the table in Excel, the same way we can, treat this what to call a data frame like that. Fine. So how to create a data frame? So we have pd.data frame, and again here we can pass list, we can pass tuple, we can pass series, we can pass dictionary. All these things we can pass. So I am creating a data frame. Generally, we use a dictionary. So I am creating a dictionary, let's say EMP equal to, and it is a dictionary. For example, I say name. So I have the employee data of a company and how many names we have, different names. So let's say we have, Roshan. Then let's say we have, Akshata. Then we have, Tim. Then let's say we have these a few names we have. Okay, how many names we have? 5 names, let's say. Then we have the corresponding codes. So how many codes we have? The same number of codes we have. Let's say 101 is the code, then 102 is the code. Then somebody, 103 is the code, 104 is the code, 105 is the code, like this. So these are the codes. Now we have the attribute, let's say city. So we have, different kind of city. They belong to different cities. Let's say he belongs to Mumbai. Then somebody, belongs to, let's say, Noida. Somebody, let's say, belongs to Pune. And, this from Bangalore. Or 1, 2, 3, 4, 5. Okay. Now, let's say next we have let's say company. We can say he works in TCS. Then somebody works in Infosys. And he works in Kailash. And he works in SCL. And he works in. Right. So these are the companies. So if you say it's a dictionary, it's a dictionary. If I say EMP data, it's a dictionary. Now I want to convert this dictionary into a table. So what can I do? I can say pd.data frame. And here I can pass the employee. And if I execute, see, we have converted it into a data frame. So when we create a data frame from a dictionary, so whatever the keys we have in the dictionaries, those become the names, column names, and the values becomes the values. So let's say this data frame name is DF, and I say DF. So this is the data frame we have created. Fine. So does it look like a table in Excel? So we have, it's a 2D structure. Why? Because we have rows and columns. On the left side, we are getting the indexes. So if you want to work upon, different attributes on the data frames, then you can say df.index, and you are going to get all the indexes. The start is 0, stop is, 5. So 5 elements we have in this. Okay, this is the index. Now, for example, you want to extract a particular column, you can say name. And it is going to give you all the values from name, like Roshan, Akshata, Tim, Nitin, and all. For example, you wanted to look like a data frame, you can pass the double square brackets and you are going to do them like this. Okay, so this is the name. Fine. So what we do, it is a small data frame. So I will tell you more on it. Okay, because ultimately we have to work upon the tabular data. So we can import a CSV or XLSX file in pandas. So how to import a CSV file? CSV is stands for the comma separated file. Okay, so we have pd dot read underscore CSV, and here we have to pass the path. This way we can import a CSV file. So if I show you, we have this Titanic data set titanic.csv. So we are going to import because it is in the same drive. So I don't have to pass the path. I can simply do what? pd.read underscore CSV, and I can pass this Titanic dot CSV. this spelling mistake. And see, we have imported the CSV file that has 891 rows, 891 rows and 12 columns. So it is a data frame, it is a table. Yes or no, my friends? This is a table. So I will tell you how to work upon the tabular data with the help of this data set. So what I'm doing, I'm storing it in a data frame, let's say data equal to, and if I say print data, so this is the data. So we have total 891 rows. So in the between, it is just hiding some rows because otherwise, like sometimes we have millions of rows, so it is not going to print all of them. So it hides a few rows. It is showing the first few rows and the last few rows. So if you want to get the first, we have the attribute data.head. If I say data.head, it is going to show you the first 5 rows. Only first 5 rows we are getting. If you want the first 10 rows, you can say 10 and you are going to get the first 10 rows like this. Okay, we are going to get the first 10 rows. The same way you want to get the last rows, so you can say tail function and it is going to give you the last 5 rows. We are getting the last 5 rows of the data set. So on the left side, like 886, 887, 888, these are the indexes we have, and here we have the column name like passenger ID, server P class and all. Okay, now you want the last 10 rows, then you can say like 10 and you are getting the last 10. Fine. This is it. Now we have the info function. So it gives the basic information about the data. If I say data.info and execute, we are getting the information about the data. It is a pandas data frame. It has total 891 entries. It means we have 891 rows where the indexes of 891 rows is from 0 to 890. The first index is 0. The last index is 890. Remember, whether we use list, tuple, dictionary, not dictionary, list, tuple or array, series or pandas data frame, the first index is always 0 by default. The first index is always 0 by default. Then it is telling total 12 columns we have. This is the column index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the column index. And these are the column names we are getting. Here we are getting the data type of all the columns, like passenger ID is the integer column, survived is the integer column. Then name is the object column. If we have in any column, if we have a string data or heterogeneous data, then it has been converted into the object column. Remember that. If we have heterogeneous data or string data, then the column of name or column data type will be object always. Fine. If you show at the bottom, if you see at the bottom, so it is saying like 2 float columns, 5 integer columns, and 5 object columns we have. So it means 7 numerical columns and 5 object columns we do have in this array. If you see a not null entries, so it is telling 891 not null values we have. It means we don't have any null values. But if you see the age column, so it means we have a few null values in this 714. It means we have a few null values in, right? So in what to call cabin column, if you see, we have a lot many null values. So we have to we have to do something about that. We will see. So this is the info attribute info function that is going to give some basic information about the data frame. Fine. Next we have the describe function. So what it does, it returns the statistical summary of the numerical columns only. Of the numerical columns only. So if I say data.describe and I execute, so we are getting the statistical summary of the numerical columns, like the count, mean, standard deviation, minimum value, maximum value, and these are the percentile value, like 25th percentile value, 50th percentile value, 75th percentile value, and so on. Fine. So we don't have to we don't have to separately check for the what is the minimum, what is the maximum, or what is the particular standard percentile value or the standard deviation. You just use the describe function and it is going to tell you the statistical summary like that. Fine. Apart from that, if you want to check the shape of the data, you can say shape. It is telling you 891 rows and 12 columns we have. Okay. If you want to know the column names, all the column names in the data, then you can say columns. and you are getting the column names. Passenger ID, server P class names, X, age, CBSP, parts, and ticket and all. Fine. Now, the most important is the handling the null values. That is the very, very important thing that we do actually with any data set. Handling the null values. So null values are the missing values actually. Null values are the missing values in the data. Okay. So if we want to do something with the null values, and those are represented np.nan and what else? So how to check for the null values? For that we have data frame name dot is null is the function is null, or we have data dot is null. Any function we can use to check for the null values, guys. Any function we can use to check for the null values. So let me show you. If I say data dot is null, execute, it is giving me the data frame of Boolean values. Where we have false, it means that value is not a null value. Where we have true, it means that is a null value. If you say like in cabin column, we have true. A lot many trues we have in the cabin column. So we have null values in cabin column, some trues we have. Some null values we may have in age column, like true we have here. But it is not easy to read, right? So what we can do, we can pass the sum function, and it is going to give the sum of the null values in each column. So you can say in each column we have 177 null values, and in cabin column we have 684 null values, and in embarked column we have 2 null values. Understand how to check the null values? The same way we can do data dot is na, and I say dot sum, and it is going to give me the null value. So you can use any of the function is null or is na. So if we don't use this sum, it is going to give us a Boolean data frame that is not easy to read. So we just pass the sum function. What this sum function does, it is going to count all the trues. Okay, the integer value equivalent of true is 1. So it is going to count all the trues, and where we have true, it means that is a null value. Fine. So this is how. Now we have got how many null values. So how to how to treat the null values? We have 2 ways to treat the null values. The first way, we can drop the null values. The second way, we can fill the null values with some other value. Fine. So both the options are there. We can drop the null values, or we can fill the null values with something. Okay. So first of all, dropping the null values. How can we drop the null values, guys? So we have drop na function. Drop na function is used to drop the null values. For example, if I say data dot drop na, okay, and execute, it is going to drop all the rows. Okay, it is going to drop all the rows where we have at least one null value. Now earlier, how many values we have in the data set, guys? If you see 891 rows we had, 891 rows we had. Now this drop na function has deleted all the rows where we had at least one null value. Now the data set has been reduced to 186 rows only. Now how many rows we have? 186 rows. So this is a very disastrous function. Why? Because it is going to reduce the size of the data, and that is not a good thing. For example, this particular row, if it has only one null value, the whole row will be deleted, and it affects the different columns, right? It is going to affect the different columns. So it is not the good idea to drop the null values when we have different null values. Okay, so many null values. And if I say data again, So you say again, I am getting the 891 rows. So what happens? It does not make the changes in the existing data set. If you want the changes to be made in the existing data set, you have to say in place equal to true. Remember, when you say in place equal to true, the changes are final. The changes are final. It means it is going to drop all the null values in the existing data set I executed. If I execute it, you can say in the data I have 186 rows. If I say data dot shape now, we have 186 rows. So this is a disastrous function, guys. So now remember, once we work in pandas, we don't have control Z. We cannot do anything undo. Once we do make any changes, the changes are final. Now, if I want to, I cannot get back all the rows which have been deleted. If I want them back, so I have to load the data set again. Getting my point? So what do I need to do? I have to load this data set again. If I say data, again we are getting 891 rows. And if I say data dot is null, dot sum, we are getting the null values. And if I say data dot shape, we are getting all 891 rows. So I have shown you how to drop the null values, and it should be avoided because it is going to reduce the size of the data. The other way around is what we can do, we can fill the null values. So we use fill NA function, guys, and here we can pass the value which you want to fill with. Fill NA function. So for example, in the age column, we have null value. So age is what? Age is a numerical column, right? Where it is a numerical column. So in numerical columns or discrete columns, what we generally do, we fill the null values with mean value or median value. Okay. With mean value or median value. So how to calculate the mean or median? We can say data dot age. We are getting the age, okay, a value of age in the age column. And if I want to get the mean, I will just say mean function, and we are getting the mean value. So mean is 39. If I want to get the median value, I can say data dot age and dot, I can say the median function I can use, and I'm going to get the median value. Fine, so median is 28. Now you can fill the null values with either mean or median, or you can fill with 0 or any random values. It doesn't matter. So let's say I want to fill the age column with the mean value. So how can I do that? I will say data dot age dot fill NA, and here I can say data dot, I want to fill the mean value. What is the mean value? It's 29 point something. So I can manually pass 29, or what can I do? This function or this statement or this instruction is going to give me the mean value. I'm just copying, and you can pass here like this. Execute. So it has filled the mean value. Okay, it has filled the age column with the mean value. But if I show you again, if we check the values again, the null values, I execute it here. Still it is showing the null values in the age column. Why? Because when we use this fill NA function, it is not going to make the changes in the existing data set. It returns the new data set. If we want the changes to be made in the existing data set, we can say in place equal to. Can you see in the age column, we have 0 null values now? Yes, guys. Please tell me how to handle the null values is clear to you or not. It is a very important aspect. Like, null values are, these are the headache. We have to get rid of them anyhow. So either we can drop the null values, or we can, what do? We can fill the null values. If you see the cabin column, let's read the cabin column now. In yes. So in the cabin column, we have a lot many null values. Remember, if a particular column has a lot many null values, so we drop that particular column. Okay, we drop that particular column. So let me show you how to drop a particular column. So we say data dot drop function is there, and here you can pass the column name, and you have to say access equal to 1. And if you want the changes to be made in the existing data set, then you have to say in place equal to true. So this is the function that we use. Access equal to 1 means, see guys, if it's a 2D data, a 2D structure. So when we say access equal to 0, top to down, the interpreter reads the data top to down. When we say access equal to 1, it is going to read the data left to right. Now we wanted to read the column names. So column names, it is going to read left to right like this. So that is why access should be 1 always. Fine. Now I want to delete the cabin column. Okay, I want to drop the cabin column. I say drop the cabin column. So how can we drop? I can say data dot drop, and here I can say cabin, and I can say access equal to 1. Execute. Can you see we don't have the cabin column? Guys, please mute yourself. Please mute yourself. Please mute yourself. So guys, I have muted you. So if you have any question, you can unmute yourself and can ask me. Fine. So if you can see, we don't have the cabin column here now. It has been deleted. Earlier we had a cabin column. Can you see? Cabin and embark. Now we are not getting the cabin column. But if I print the data again, see, we are still having the cabin column. Why? Because we have not passed in place equal to true. If I say in place equal to true, the changes will be fine. If I show you data, see, we don't have the cabin column. Okay, now I want to drop the multiple columns. So how can we drop the multiple columns at the same time? Let's say I want to drop this name column and ticket column together. Okay, name, ticket, and embark. These 3 columns I want to delete. Passenger ID. We can remove passenger ID, name, and ticket. Okay, drop passenger ID, name, and what is that guys? Ticket columns. So what can we do? We simply say data dot drop. When we have multiple columns to be dropped, then we just pass the names in a list. Okay, spelling should be the same. It is case sensitive. So I'm copying from here passenger ID inside the quotation mark. The second is the name, and the third is the ticket. Order may be anything, and then we have to say access equal to 1. Execute. You say passenger ID, name, and ticket all have been deleted. But if I print the data set again, if I say data, you say we are still having them. So if we want the changes to be made, permanent, then what we can do? We can say in place equal to execute. If I print the data now, you see we don't have the passenger ID, name, and ticket. So this is how we can drop the multiple columns. Is it making sense, guys, till now? So we have seen like how to handle the null values, and we have seen how to drop the particular columns. Now if I talk about the data set, so what we do actually in data set, we have different type of value. Generally we divide them into 2 categories. One is the numerical category, second is the object category. Numerical, we have integer or float values. If I talk about the object, so in object it may be string, it may be heterogeneous values. Now you want to split your data set into 2, like where we have numeric and object columns separately. so that the working on them is easy. So we can do that also. So splitting the data set into numeric and object. So we use, guys, data dot select d types function. Okay, this is the function that we use. Now, for example, I want to create the numerical data, let's say num data equal to, and I can say data dot select d types, and here we can pass numbers, just number. Execute. If I show you num data, can you see in the num data we are getting all the numerical columns now? If I say data dot head, all the rows, but only the numerical columns we are getting. Fine. If I want to get the object data, let's say I am giving the name, or let's say object data equal to, and we can say data dot select d types, and here we can pass the object. Execute, and if I say object data, we are getting the object values only, like sex and embark. Only two columns we have the object columns. So this is how we can split the data. Okay, like this. Now this is a bit I have discussed, about how to work upon the null values and all. See, guys, there are many things to do, but because of the time constraint, we cannot discuss each and every point. Okay, so what I'm trying to tell you, what is the most important things I'm trying to convey them. Fine. So let's talk about a bit about this visualization in Python. Visualization, like if you want to plot the graph or chart or something, so for that we use the matplotlib library. It is used to visualize the data. Fine. So we have pyplot module inside the matplotlib that we use. So first of all, we have to import. Okay, we have to import matplotlib. So we have how to import matplotlib. We say import matplotlib. Then inside the matplotlib, we have pyplot module, guys. Matplotlib.pyplot, and inside the matplotlib is the library name, and pyplot is the module that we use to plot the data. Okay, so any function, if I want to access from the pyplot module from matplotlib, I have to use this every time. So what we can do, we can give some name, let's say plt, and I execute. So with the help of plt, we can with any function from this. Fine, any function we can access. Let's say I am creating two arrays, like say array is np.array, and this array I have some elements 1 2 3 4. So these elements we have. Okay, this is array 1. Now I have array 2 equal to array into 5. Fine. So these two arrays I have created. This is the array and this is the array 2. Now I want to plot these arrays. So what can I do? I say plt.plot, and I can say array comma array 2. So plot is the universal function that we use to plot any data. So on the x-axis we have array, on the y-axis we have array 2, and we are getting this plot. If you see, we are getting some extra information here, matplotlib.length line 2d, and this is the hexadecimal address it is showing. If you don't want this extra information, you can say plt.plot show function, and it is not going to show you this. Fine. This is going to give you like this. If you want to increase the size of the plot, then you can pass plt.figure object here, figure function. Inside this figure function, you can say figure size, fixed size equal to, and it takes a tuple. You can say let's say 8 by 6, execute. The size has been increased. You can increase or decrease the pixel size also. Let's say I'm saying 6 by 6, sorry, 6 by 6, and I want to increase this pixel size. So DPI, density per inches, and I say 100. Can you see it looks better now? Yes or no? So this way you can increase the pixel density also. Let's say I make it 200. Can you see it is more visible now? It is more visible. So if we increase the pixel density, size gets increased also accordingly. Fine. So let me have it as 0, 100. Fine. Now if you want to change the color, so in the plt.plot function, you can pass the color attribute, and let's say it should be red. Now the color is red. If you want the markers to be printed here, then you can say marker equal to, and different markers we can pass. Let's say first is O, we are getting the markers. Right. If you want to increase the marker size, then you can say marker size, and let's say I make it 5. So let me make it 10. So marker size has been increased. If you want to give some other color to the markers, then we can do like marker face color attribute, and let's say I make it aqua. So this is the marker face color. We can do like this. Fine. You want to give the title to this plot, then you can say plt.title function. And here you say this is the plot we have plotted. So this is the title we have. We can, if you want to give the name to the X and Y axis, we can do that also. We have to say plt.x label, and here we can say let's say we say this X axis, and this way this is the we are getting the X axis. You want to give name to the Y axis, we can do that. We have to say plt.y label, and here we can say Y axis. We are getting the name to the Y axis. So this is plt.plot, okay, plot function. That is the universal function from matplotlib that we use. If you want to increase the size of the figure, you can say plt.figure, and you can pass fixed size attribute, and accordingly you can increase the width and height. So 6 is the width and 5 is the height. DPI is the density per inches. You can increase or decrease the pixel density also. Is it making sense, my friends? So all this stuff we can do. Fine. If you want to save this figure, we can do that also. So you can say so we have to pass for one attribute like fig equal to. This is the figure attribute, and if I show you now, can you say plt.png has been created? And if I show you in the editor, this plot looks like this. Now, if you want, you can use it in your PowerPoint presentation or anywhere you can use it. This way you can save it. Is it making sense? Please tell me. Fine. Now, if we want to have a different kind of plots, so we use the seaborn actually. We can do in matplotlib also, but matplotlib doesn't, the plot doesn't look better actually. Let's say if I want to learn how to plot a scatter plot. So we can say plt.scatter plot, and it takes, plt.scatter, and it takes 2 values. If I show you the data, so we can pass 2 numeric columns. So if you say age and fair are the 2 numeric columns, so we can say like this: data.age and data.fair. what is that? Here. This is the scatter plot. This is the scatter plot. Again, we are getting some extra information. If you don't want this, we can say PLT dot show. If you want to increase the size, you can use the figure attribute in that case. So it is telling you the density. So how to read it? You can say on the x-axis we have age, on the y-axis we have fare. So fare is somewhere 500 euros. Only two people are there who are paying around 500 of euros. Fine. And most of the people, they are paying less than 100 euros. A few people, they are paying between 200 and 300. The same plot we can plot in Seaborn, but Seaborn plots, they look better. Fine. So instead of plotting in Matplotlib, what we are going to do, we are going to plot them in Seaborn. Let me show you the box plot also, so that you can have some idea. Box plot we can plot that gives us the statistical summary and outliers also. Tomorrow I will explain what is an outlier. So we can say data.h, and this is the box plot. We are getting some extra information, as I said, all this information. If you don't want this information, what we can do, we can say plt dot show function, and we are not going to get this information. If I want to increase the size of it, again I have to say plt dot figure, and I say fixed size equal to, and I can say like 6 by 8, and the density of pixels, I say, let's say 100, and the ratio, so it is bigger. Yes or no? Fine. So these are the outliers. Okay, like outliers are the data points that are significantly different from the rest of the data. Okay, so tomorrow I'll explain what an outlier is. So this is this is known as the upper whisker. This is known as the lower whisker. Okay, this orange line, it is telling the median value. This upper boundary, this one, it is telling this 75th percentile value. It tells about the 25th percentile value. 75th percentile value is known as the third quartile value. It is known as the first quartile value. Okay, so this is the box plot. All this stuff we can do in Seaborn. Fine. So Seaborn is nothing but it is the extended version of Matplotlib. So if we import Seaborn, we import like this, import Seaborn, that's it. And we can say as SNS. I mean, we have just given a name so that we don't have to write Seaborn, again and again. Fine. So we can do like that. Fine. Understood? So if I want to plot the scatter plot and box plot in Seaborn, so you can say, if I say SNS dot, we can say box plot. And if I say data dot age column, so it is creating the box plot and it is giving me the warning message. Okay, it is giving me the warning message. So if you don't want this, what we can do, we can pass the column name on the axis. Like, let's say on the x-axis, I want age, and my data name is data equal to data, execute. So you can say on the x-axis, I am getting age, and our data name is data. So we have outliers on both sides in the age column. If you want it to be printed on the y-axis, then you can say y equal to age, and you are getting it like this. Fine. Again, you are getting some extra information. You don't want this, you can use plt.show. So which one looks better? This one or this one? Seaborn looks better. So we can increase the size of it also. So plt.figure we can use. Fine. So this is the box plot in Seaborn. So we have a lot many outliers in the age column. If I want to, create a distribution plot or the scatter plot, let's say, so I can say SNS dot, and I can say scatter plot, and here I can say data dot. What is that? Two columns we can pass. Let's say age. Instead of this, we can pass as the x and y. Okay, like x equal to age, and y equal to, we can say pair, and our data frame name is data. Execute, and we are getting the scatter plot like this. Again, we don't want this extra information, we can say plt dot show. We are not getting this extra information. Fine. If you want to increase the size of it, so again we can say plt dot figure, and we can say fig size equal to, and let's say 6 by 6, and I said dpi equal to 100. So size has been increased. Like this. Fine. Here, if you want to look the spread of the data on the basis of a particular categorical column. So if I show you the data, so sex is the categorical column, P class also the categorical column, survived is also a categorical column. So P class is the passenger class. You want to get the spread of data according to the passenger class. You can pass one more attribute, let's say hue equal to, and you can pass here P class like this. And according to P class, we are getting like this. Fine. But it doesn't look, very much better. So we can pass the attribute, let's say palette. And if I say bright, fine. So we can have the palette. So green is, this is the, legend we have. So yellow, blue is representing the class 1, orange is representing class 2, green is representing class 3. Fine. So you can say a lot many people, they belong to class 1, and a lot many people like who belong to class 3, they are paying less than 50 euros or something. Understood? The people who are paying somewhere around 500 euros, they are from class 1, like that. So you can do in that. If you want to get the distribution plot, okay, you want to check the distribution of the data, then you can use sns.distplot. Let's say you want to say data.age and you want to get the distribution. So by default, you are getting a histogram like this. Okay, you're getting a histogram. So I say plt.show. You can set the theme also. So if I say sns.set theme function we have here, you can pass the grid style with the name of a style attribute, and style, let's say I say white grid. So if you want the grid in the background, you are getting the white grid like this. Fine. You can pass the palette also here. Let's say palette I want to be bright so that it looks better. Fine. And scaling also we can pass with the name of context. Context we can, by default it is notebook. Different context you can pass. This is notebook, and if you want size a bit bigger, then you can say poster. You're going to get like this. So by default it is notebook, so let it be notebook. You can say white grid. You can say dark grid also. If you don't want the white grid, you can say dark grid, and you are going to get the dark grid. If you don't want the grid, you can just say dark, and you are going to get it dark like this. If you don't want anything in the background, then you can just make it white. Fine. So this way we can. So let me make it as white grid, and it is like this. Fine. So if you want to increase the font size, so we can pass the font scale attribute here. And I say, let's say I say 2. So font has been increased a bit. Let's say I say 1.5. Fine. So this way we can do. Is it making sense, my friends? Please tell me. If you want to get all the attributes, you can say shift plus tab, and you are going to get all the attributes available in this function. Now, for example, you want to increase the size of it, then you can pass the height attribute. Height, let's say I say 5. So it is already 5. So let me make it 9. So height has been increased. You want to increase the width, then you can pass the aspect attribute here, and I say, let's say 2. So you are getting this. Right? So you are getting the distribution. Fine. So you can pass the kind also. Kind by default it is a histogram. Hist means histogram. KD equal to 2. Yes, if you want the density line, then you can say KDE equal to true. Fine. You can KD equal to, so this is known as the kernel density estimation. If you don't want this histogram, okay, then both of them together, then you can use the hist plot also. So we have, let me use this theme here also. And we can say SNS dot hist plot. And I can say data dot age. Fine. So this is the distribution plot, and his plot, whether you can use the histogram or you can use this dist plot. It is up to you. So here you can say KD equal to true. You are getting this density line. And can we pass the kind attribute here? Just a second. So no, we cannot pass the kind attribute. You don't want this extra information, then you can say plt dot show. If you don't want the histogram, you want the density only, then you can pass here. So by default you are getting count. If you don't want the count, you can pass different. So you can say stat attribute here. Stat equal to, you can pass, let's say frequency you want, and you can get the frequency. STAT. It has to be frequency. So you are getting frequency. If you don't want frequency, you want density, then you can get density also. You can say density here and you can get density. You're getting density on the website. So this is you can do. If you don't want this histogram, you want the density also only, then you can use the SNS.kde plot. And you can say data.h. Sorry, it is capital. And you are getting the density. Fine. We can use plt.show. If you want it to be shaded, then you can say shade equal to true. So this way we can use different kind of plots. So we are running out of time now. So rest of the plots I will show you tomorrow, and then we will take the case study. So tomorrow we may spend more time. Okay. So generally, I hope you have got the idea. If you want to work upon the numerical computations, then we use what? NumPy. If you want to work upon the tabular data, then we use pandas. And if you want to work upon the visualization, then we use matplotlib and seaborn. Any doubts, my friends? Tens, I'm not sure, so I'll ask. Just give me a second, like whether the recording is available or not. Just give me a second. Yes, Vishwanath, I will tell you tomorrow, like when we're going to work upon the case study. So today I'm just telling you, how to plot a particular graph and how they are useful for us. So we will discuss tomorrow. It is not just these graphs, we have many more. So we will discuss them first, and then I will tell you with the help of case study. Fine. So now Karishma is there. So if you have any doubts related to course or the content, or whether you're going to get the recordings and all, or the data set, then you can ask her. Okay, Karishma, are you there? Karishma, can you hear me?
Yes, sir.
Yeah. Hello, Karishma. So guys, she's going to guide you. Rest we will see tomorrow. Then we will see like how to plot different kind of plots and how they are useful in our analysis. I will explain everything tomorrow. Fine. I hope you all are doing well, guys. And first of all, I welcome you all in this session. So let's start. So today we are going to do a case study. So yesterday we had, a bit of introduction about Python and the libraries. So let's start. First of all, let me tell you a bit about the analysis that we do, guys. We have three types of analysis that we generally do. The first one is the, we call it a descriptive analysis. The second one is the prescriptive analysis. And the third one that we have is the predictive analysis. These three. So a descriptive analysis is what? Descriptive analysis is the analysis of the historical data. The analysis of the historical data. Okay, so let me write in the new line, that will be better. It is the analysis of the historical data is known as descriptive analysis. It tells what has happened over a period of time. This is called as descriptive analysis, and it is generally, done by the data analyst. So data analysts are the ones who do the descriptive analysis. They have some historical data and then they, have a look like what has happened over a period of time. Fine. The second, we have the prescriptive analysis. Okay. Prescriptive analysis is, it is finding the best possible solution for a given problem. Okay, it is just finding it. So what happens, like when we have some descriptive analysis, so data analysis, they tell like we have we are facing some problem in this particular area or this one. So like if the sale is degrowing over the period of time, then what is the cause of that? Okay, so prescriptive analysis is finding the cause of the problem and then finding, trying to find the best possible solution for that problem. Okay, it is known as prescriptive analysis and it is done by the business analysts. Is it making sense? Descriptive analysis and prescriptive analysis. Now the third one that we have is the predictive analysis. Predictive analysis is, what may happen in the future. It is the prediction about future on the basis of the given parameters. Fine. It is the prediction. It is the prediction of the about the future. Fine. So it tells what may happen in future with the given situation and parameters. It is generally done by the data scientists. So these are the three kind of analysis that we generally do. Okay, descriptive, prescriptive, and predictive. Sorry, it is predictive analysis. Fine. Any doubt in this? Is it clear? So descriptive analysis is when we work on the historical data and when we try to find out the pattern. Okay, like what is the pattern in the we have got in the period of time over the period of time in the past. So today we are going to discuss about the descriptive analysis. Predictive analysis is something that we do in machine learning. We create a model and that model is going to give us predictions. Like if we whether somebody is going to take loan or somebody is going to deposit money in the bank. Such kind of analysis is known as predictive analysis. Fine. So today we're gonna do the stock price analysis. So first of all, let's import the libraries. So first of all, I'm saying import NumPy as NP. Then we have to load the data set. So on the data set, we have to work in pandas. So import pandas as PT. Then we have to use some visualization tools. So I'm saying import matplotlib.pyplot as PLT, and then import Seaborn as SNS. And I don't want extra warning messages, so I can say import warnings, and then I say filter warnings dot filter warnings, and here I can say ignore. Fine. So let me tell you, this is for the numerical computations. This is for data manipulation. This is for visualization purpose. And this is also for visualization. Fine. And this one we are using just to avoid unwanted warnings. Execute. So we have successfully imported all the libraries. Any doubts till now, guys? I hope you're getting. So you can ping in the chat box if you have something to ask. Fine. So we have to load the data set. So we say pd.read CSV, and here we pass the path or the name. So this is tesla.csv is the file that we are going to work upon. So sorry, it is TSLA. And if I say data.hand So this is the data. This is the Tesla company's data. Okay, and we have the date from 2010 to 2020, and then we will analyze the stock price. Okay, so generally when we see the stock price, so we have opening price, like of the day opening price, and the day closing price, and we are getting the highest it went and lowest it went. But that is the most important column for us is the closing price. Okay, what was the closing price on a particular day? Like this is the date 29th of 6th of 2010. The closing price was $23. Okay, so the values are in dollars on this particular date. The closing price was this, and on this particular date the closing price was this. So when we work upon a data set, so the first step that we do is known as the EDA, guys. It doesn't matter what kind of data set you are going to work upon. Okay, the first step that we perform is the EDA. EDA stands for exploratory data analysis. Exploratory data analysis. What is exploratory data analysis? It is nothing it is the exploration of the data. That is known as exploratory data analysis. It is the process to know more about the data. Okay, or you can say it is the process to get insights as many as we can from the data. So that is known as exploratory data analysis. Is it making sense, my friends? Just let me know, say yes or no in the chat box, please. What is exploratory data analysis? So when we have any kind of, see, it doesn't matter like when you are going to work in the real world. So data is of different type. We are not sure like what kind of data we're gonna have. Okay, so it doesn't matter what kind of data do we have. The first step that we follow on any kind of data is the exploratory data analysis. Fine. Whether you are working as a data analyst or you are working as a data scientist, the first thing we do is the EDA. Fine. So in EDA, there are a few steps that we follow with any kind of data set, and rest of the data, steps we follow according to the nature of the data or the problem that we are going to solve. Fine. So if we talk about the first of all, we check the shape. That is the most important part. Shape of the data. Shape means how many rows or how many columns we are going to work upon. Right. So to check the shape, we can say our data frame name is data, and I say shape. Execute. So we have 2416 rows and 7 columns. So if you see, we have 7 columns: date, open, high, low, close, adjacent, close, and volume. And we have 2460 rows, 16 rows, sorry. Fine. Now we want to have a column names, for example. Column means, see, here we are having only 5 columns, so we can easily have a look on the names. But sometimes what happens if we have 50 columns, 500 columns, sometimes it happens like we have 200 columns. So it is not easy to read all the names. It is going to hide the column names. Okay. So if we want to get all the column names, then we have to say data.columns, and we're going to get all the column names. Date, open, high, low, close, adjacent, close, and adjoining, close, and volume. Fine. So this is the columns we have got. Now we have to get the a basic information as we did yesterday. So you can say like data information. So for that we have data.info function. And again we are getting the information. So you see, like we don't have any null value. We in each column we have 2416 values, and the data type date is object, open is the float. Okay, so only one object column we have, and rest of the columns we have as the numeric columns, right? And total 2416 entries we have. Fine. We can check for the duplicates whether we have some duplicate values or not. Okay. So if you want to check the duplicates, we have to say data dot duplicated function is there, guys. So if we have duplicate, it is not a good thing. Okay. It is going to give us the Boolean array. Okay. Boolean series, true or false. So we have to use the sum function and it is going to give us. So 0 duplicate values we have. So it is a very refined data. We don't have any null values. We don't have any duplicate values. Even if you want to check for the null values, so we can use data dot is na dot some function. Sorry.
बस इतने ही बोले हैप्पी बर्थडे
हाँ enjoy your day.
So we don't have any null values.
यहाँ का रूल होगा
Guys, please mute yourself if you're not asking anything. So I have muted all of you. If you have anything to ask, you can unmute yourself and can ask me, or you can, drop in the chat box. Fine. So is it making sense till now, my friends? So this is the basic, things that we want to know about the data, like what is the shape, what are the column names we have, okay, what are the data types, and whether we have duplicate values or null values. If you just want to get the data type also, so then you can say D type, so attribute, and it is going to give you the data types only. So object, float, and all. Okay. So only one integer, and rest of the values we have float and one object column that we have here. Fine. Is it clear till now? Now we come to the analysis part. So if you see the date column is the object column, and if I want to play with dates, so it has to be converted into the date time format. It is not in the date time format. Object, it is a string value. Okay. If I say object means it is a string value. Fine. So first of all, let's convert. Let's convert the date column into date time format. The first thing is this date column has to be converted into date time format. To convert into date time format, we have the function pd dot to and date time, and we have to pass the date column here. Okay, and this date column is from where? This date column we have from data. Can you see the structure is changed now? Earlier we have the this slash character in the date column. Now what we are having, the hyphen. Now it has been converted into the date time. Can you see? Date time 64. So I am assigning it back to the data column, date column. Execute. And if I say data dot head, so can you see the date has been changed now? The structure is changed. Earlier we were having the hyphen. Okay, sorry, this backslash. Sorry, forward slash, and now we are having the hyphens. If I check the data types now, can you see our date column is the date time? It is in date time format. Earlier it was the object column. Understood? Now we can extract the months and years or the days, whatever we want. Fine. Anything, guys, till now? Just a second. Now I want to check the the trend of the closing price. Okay, I want to check the trend of the closing price over the period of time. Fine. So we can say data close, or we can say plt.plot function, plt.plot, and we can say data closing price. If I do this, it is going to throw me an error. It is not going to give me the trend. So it is giving the trend, but if you see, we are not getting the dates here. Trend means we want to have a look like whether over the period of time it is increasing or decreasing, or what is the fluctuation we are getting. Fine. So here, if you see, we are getting the count, but we are not getting the dates. So to overcome this problem, what can we do? This date column has to be converted into the index. This date column has to be converted into index. Before doing that, what I am trying to do, let's create one column of the year and one column of the months. Fine. So I can say I want to create a year column. And this year column, how can we create? We can say from data date. And we can use, let me show you. We can use, dot year. If I say this, we are getting the years. Yes or no, guys? From this date, we have extracted the years only. If I want to extract the months, I say month, and we have extracted the months only, like 6, 7. These are the month names. If I want to just get the date, we can say day, and we're gonna get the days. 29th, 30th. So these are the dates. So what I want, if I say year, we are getting the years, and I want to create a new column with the name of year. We simply do like this, equal to, and give the column name what you want to give. Let's say year, and execute. And if I show you data dot head, can you say a new column has been created with the name of year? And we are just getting the year only from the date, 2010. Yes, everyone. Is it making sense? Now I would the same way I want to create the month column. So what can I do? I can say data month, and it should be from data date. And then we have to say dt means date, time, and dot. We want the month. Execute. And if I say data dot head now, we have got the month column. So month is 6 here, we are getting 6 here. Month is 7 here, we are getting 7. So what we did from the date, we extracted year and month. Day is not required actually. Okay, so let's leave the day only. So year and month are enough. Okay, year and months are enough. Now what I need to do, I need to convert this date into the index column so that we can get the trend over the period of time that we are not getting here. So what I'm doing, convert the date column as index column. So we can say data dot set index, and here you can say the date. Execute. Can you say the date is the index column now? Yes. Earlier the date was a column name. It was a column. Now it is an index. And how many columns we have? 8 columns. 1, 2, 3, 4, 5, 6, 7, 8. This date is not a column now. It is the index. But if I print the data again, you can say like date is again here. So what can we do? Anyone? We discussed it yesterday. If we want to make the changes in the existing data set, what can we do? Yes, great, everyone. So what can we do here? Here we can say in place equal to true. Execute, and if I say data dot head, see, now the date column has been converted into datetime format, and it is the index now. It is the index now. Very good, guys. Now I do the same thing again. I want to plot. I want to see the trend. So first of all, let's set the theme. I am saying SNS dot set theme function, and here let's say style equal to let's say white grid. Context equal to, I say, notebook. That will be fine. And palette equal to, let's say, right. Fine. This is. Now I want to create this figure size, plt dot figure. And here I say fixed size equal to, and let's say it is 8 by 6, and I set the DPI to 100. And then I use plt dot plot, and now I say data, and I want to plot the closing price. Execute. Sorry, small. Yes. Are you able to see the trend? Now I don't want this extra information. What can I do? I can say plt dot show function. If you see on the x-axis, we are getting the dates now: 2011, 16, 17, 18, 19, 20. But earlier, when the date column was not the index column, we were not getting the dates here. So it was not the trend according to the time. We were just getting the counts, right? Now we are getting the dates. So what can you say after having a look on this, everyone? Of course, we have some fluctuations here. Okay, but if we analyze the 10 years of data, so stock price has increased a lot. Yes, from 0 to, and it has, hiked to 800 euros something. Sorry, $800. This is the closing price. This is the closing price. Yes. So in the highest peak we have got in the 2020. Before 2020, it was, somewhere around 200. Is it making sense? Fine. Now I want, if you want to get the year-wise analysis, like what was the value year-wise? Okay. Year-wise. Now what I want? Year-wise close price values. Year-wise close price, status I want. So we can use the group by method, guys. We can say data dot group by. And here we can pass the year. Year-wise we want the value, and what we want the value of the closing price. So I can say close. And what do we want? Let's say I want to see in each year we have different values. Day-wise we are getting the value, so we can take the mean value of the year. Agree my point? Like what is the average value at the end of the year we are getting? So it is giving me the price on the basis of the average. So in 2010 the average price of the share was 23, closing price, sorry. 2011 it was 26, in 2012 it was 31, 2013 it was 104, and 2014 it was 223, something like that. So this is where, if you say in 2020 the closing price was the highest, it was 540. Is it making sense? How can I know, like, can we analyze? Are we getting some insights from it? So in 2010 the average closing price was 23, and in 2020 the average closing price was 540. Now, if we want to plot it, so we can create a new data frame. I can say df, okay, and equal to, I can say pd dot data frame. And here in this, I can pass this. If I show you df. So this is the year. Year is the, we are getting what? Here is the indexes, and here closing is the average value. Okay, if you want to give the column name, then you can say columns equal to so this is the mean value we are getting. Understood? And if we want the years, so we can create a new column year here also, and this one. If I want to extract the years from this, so what can I do? I can just say index. If I say, let me show you in the new line so that you can understand. I want to extract the years only. So I'll be saying dot index. Can you see we are getting the years only? If I want to get the values only, then what can I do? I can say dot values, and I am gonna get the values only, like this. Fine. So I have created a new data frame where mean value is the values we have got, and again another column with the name of year. So what can we say here? We can take from here. I am passing this, execute, and if I show you df now, so we have two columns. We have two columns, right? Mean and year. Mean and year. Is it making sense, my friends? Any doubts till now? Please tell me in the chat box. This is the mean or the average closing price over the year. So if we want to see the trend. So how can we see the trend? I can say df dot set index, and I can say year. I can set it as index, and then I can say what to call. But if you don't want the set index, it's still we can do that. We can use this SNS dot line plot. On the x-axis, I want the years, and on the y-axis, I want the mean value, and my data frame name is df. Execute. So this is the line plot we are getting. So if we see the average closing price, so it has increased a lot over a period of time. Yes or no? Please tell me if it is making sense. Fine. So this is how we can do. This is how we can do. If you want to plot it, as the count, then we can use this is showing the trend. If you don't want to have a look on the trend, and let me just say plt dot. So we don't want to have a look on the trend. We just want to get the counts. So what we can do, we can use the bar plot. SNS dot bar plot, and here on the x-axis, I want year, and on the y-axis, I want mean, and my data frame name is df. So this is the bar plot. Let me increase the size of it. So we have increased the size. So in 2010, the average closing price was, less than 100. And in 2020, it was the highest. So it is showing you the counts. Okay, mean value it is showing over here. Fine. If you want to get the values to be printed over here, so we can do like this. I can say AX equal to, let's say, and we have to say like this for I in AX dot containers. We have to use, guys, to plot this. And then AX dot bar underscore label function, and I say icon. Can you see we are getting the values? So we use this, we have to apply loop AX, assign it to any variable. Let's say I'm assigning to AX, and then you can say AX dot containers. In the containers, then we have the bar label function. Okay, and it takes a tuple value. So you just print the value of I, and you're going to get the values like this. Fine. So the mean value is 23.348 something, and here you're getting 540 something. Is it making sense, guys? Let me reduce the size a bit so that we can have a better look. This one. Now, if I want to check the trend of the closing price in a particular year over a in a particular year over a period of months, fine. Over a period of months, if you want to get to know. So let's say I want to know in 2014 what is happening over a period of months. Okay. So let's see the trend of the closing price in 2014. Right. So what can we do? Data here. So we are getting the year 2010, and I just want to get it to 2014. We are getting the Boolean array. If we want the whole data set, just pass that to the data frame. And this is 2014. So if you see, we are getting the details of the year 2014 only. Yes or no? Only 2014 we are getting. Fine. Now, if we want to see the trend, what can I do? I can say group by, and I want to check with the over the months what is happening with the closing price. So I will say close, and then again we can take the mean value, because in every month we have lot many dates. So we can take the mean value in that case. So it is giving the in first month in 2014 the closing price was this, in the second month the closing price was this, and so on. We are getting the values like this. Are you getting my point? So again, we can create a column and we can analyze a particular year. Okay, but it is going to take a lot of time. So to overcome this, what we can do like this. We can say SNS dot line plot. I want to get the month-wise analysis of the whole years. So I can say X equal to month, and Y equal to, I can say, the closing price. Close. And hue is the third attribute you can pass, let's say, according to the year I want, and my data frame name is data. So again, we have to increase the size a bit. If I say PLT dot figure and I say big size 10 by 8 and the DPI is, let's say, 100. Fine. And let me change the palette. So this is the trend, or month wise of the whole years we are getting. Guys, can't you see the screen? Please confirm. Is the screen visible or not? Okay, okay, okay. So if you see, we are getting the legends here. So you can correlate like this is 2010, 2012. Okay. So this red line, it is totally different rest of the other. So this is 2020. And if you see in the second month only, it went up to as high as, somewhere nearly 800 euros, $800. Roshan, I don't know like what the problem is. Could you please, you can do one thing, you can rejoin and then check if you can see that. Fine. So this is the trend, like, this, let's say, I want to check the trend of, let's say 2018. So it is the light orange, okay, orange line. So this is the 2018. If you say we are getting zigzag, fine. So this is the way, like you can, if all the years, and here we are getting the months together. If you see, you are getting 2, 4, 6, 8, 10, 12 like this. You are not getting 1, 2, 3, 4, continuously the months. If you want them to be continuous, then you can use this function plt.xticks, and then you can pass from 1 to 12. 1 to 12 months we have, so we can say I for I in range, and I say 1 to 13. What is the meaning of I for I in range? See, if I say, let's say LST equal to, if I say like this, I for, it is known as list comprehension, guys. I in range, it will start from 1, and if I say 13, so 13 is the stop index, stop value, and first is the start value. Stop value is always excluded. If I say 1, 12, it is going to give me the values 1 to 12. So I want to assign to the x-axis, I want to give the label from 1 to 12. So I can directly use this, or you can copy this like, and you can pass it to the xticks functions, this xtick function. If I execute this one, see, we are getting the whole 12 months now. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and accordingly we are getting the values to be printed. Is it making sense, guys? So year wise and month, along with the months, you can see the trend of any data.
Excuse me, sir.
Hello, yes.
Yeah, am I audible?
Yeah, you are audible. Please
Yeah,
tell me.
sir. That so the chart is depicting the correlation between the values in the months. What is the chart depicting?
No. It is not correlation. It
Oh,
is
it's not
showing you the
correlation.
trend over the years.
Trend over the years.
Yes.
Okay.
The closing price, and by default, when we use the line plot, it is giving you the count over here. Okay.
Right, sir. Got it.
Fine.
Thank you, sir. Thank you. Yeah.
You're welcome. If you want to check the correlation among the columns, so correlation we use for machine learning purpose. Actually, we do. Then we have the core function. You can directly apply this core function like this.
Yes. I was looking for that. Sir.
Okay.
Yeah.
You are getting the correlation between any of the two variables. Fine. If you want to print that, so let me show you how to get the correlation. So we can use SNS.heatmap. So let me increase the size of the figure first.
Sir, here, I mean, you're depicting the heat map in order to derive the multicollinearity.
Yes,
Is that
yes.
it? Okay, okay, okay. Thank you.
So this is the heat map we are getting. So we are working on which column? Data, right? So we can do. To 2 decimal after 0 I want, and I can say so you're getting the correlation like this. Fine. So where you have the this is the C bar with the where the color is yellow, that is showing the highest correlation. Where it is the dark blue, it is the lowest correlation we are getting. So the diagonals are always correlation 1. So you can say, open is correlation 1, and open with high is also correlation 1. Fine. So correlation makes a big difference. When we use the machine, when we want to feed the data to the machine learning model. Okay. But here we are doing the descriptive analysis only.
Yeah,
It
and
is
sir,
very much useful in the predictive analysis. Yes.
yeah, sir, I'm sorry for interrupting. Sir, the thing is that, sir, here when we see that multicollinearity is present, sir, then which variables will be dropped? Sir? I mean, how will we evaluate that which variables can be taken and which can be dropped?
No, see, in machine that is something related to predictive analysis.
Yes, sir,
In
I know,
that
I know. I
case, we
won't be
have
touching
to,
upon that
yeah.
today.
Let
Yeah.
me come to that point. So it is in machine learning, what happens if the two columns have the same correlation, right? Or the highest correlation, like it means both the columns are giving the same learning to the model, right?
Mm-hmm.
Like if they are having the correlation 1 or -1. So in that case, we can drop any one of them. Now the question is which one is to be dropped? That is your question?
Yeah. Yes, sir. Yes, sir. Which one is to be dropped? Yes.
Yeah. So in that case, we have to check, different factors, whether the column which we are going to delete has some null values or not. Okay. If we fill the null
Okay,
values,
okay.
then of course the correlation may change. Fine.
Right,
Apart
right,
from
right.
that, what is the variance or standard deviation we are going to have? Okay.
Yes, yes.
And in both the columns, we can check if both the columns are, which one is the nearly normally distributed. So which one is nearly normally distributed, we are going to have that one, and which one is having some skewness, we can
Skewness,
delete.
yeah, you can drop that. Okay, sir. Yeah.
Okay.
Thank you so much. Yeah.
Yeah. You're welcome. So just a second, guys. Yes, Karthike. Could you please tell me what can this also be done for the hue? We can see alternatives. Yeah, you can. It is up to you. Like you can keep the month here, then you can take year here. So and then in the hue you can pass month. Okay. So when we use the line plot, one should be the discrete or numerical column. Two columns you can have the categorical. On any axis, you can pass one categorical, and one categorical you can pass as the hue. Yes, Karthike, is it making sense?
Yes.
Any other doubts, guys? Till now, are you? So I hope you are getting it, like how to check, different parameters or the trends.
So one doubt, can we
Yeah.
pass date as a data type to our machine learning model?
If we have the time series data, if we want to work upon, we do that actually.
Oh, so the model will understand, like I'm asking, like the
Yes.
hyphen 3 hyphen like that. Can
Yeah,
we pass?
machine learning model can understand. The only thing, that column has not to be the a object column. It has to be in the date time format.
Okay, so we can pass with as a date time format thing. Okay.
Yes. It has not to be the object column. Otherwise, it will take as a string value, right?
Yes, yeah, fine.
Yeah.
Thank you.
So yeah, in the time series data, sometimes like we want to give the prediction on the basis of time, right? So
Okay.
in that case, we call it as time series analysis. So you can pass the column as in the date time format.
Okay.
Okay, but if you pass it as the object column, so it is some algorithms are not going to take. If algorithm is accepting, it may give you the false results. Okay.
Okay. Thank you, sir.
Yeah. Shall we move ahead then? So we have seen some trend, year wise, and the count, count also we have seen. Now, what do we want? We want to check the profit, what is the profit we have got. Okay, price difference we have got, and what is the wealth, at the end of the 20 years we have, made if what happens. Fine. So I say data dot. This is the data we have got. Fine. So how to calculate the, I want to create the price difference. How we can calculate the price difference, guys? Here. Or if I talk about the profit, how can we, check the profit, day wise profit, how can we do? So if I, if this is the closing price we have got, right? So if I subtract from the next day, the previous day, we are going to get the profit. Like if I say 30th and 1, in these 2 days, we got the loss of $2 or something around. In round figure, I am telling. Again, we are getting the loss of 2. Again, we are getting the loss of 3, something like that. So if somebody is doing the trading day by day, selling and, buying and selling. So what is the profit or, loss share he is making, day on the day by day basis. So how can we do that? If I, if I want to check the profit, so profit is what we can say. Tomorrow minus today. Yes or no, guys? This is the profit. Like this is the next day. From this, if I subtract this, so this is the profit or loss, whatever. If we have the value negative, it will be the loss. If the value is positive, we're gonna have this what as the profit. Yes or no? So what can we do? I want to create a new column we have the closing. I want to create a new column that has the value of the next day. Like for example, let's compare these two. So here we have 23.83. I want to create the next column. Here, instead of this, I want to get this next value. And here, for example, I want to get this next value like 19, something like that. So what can we do? We can do like this, guys. I want to create a new column. Let's say, tomorrow. Let's say I want to give the name tomorrow. Okay. Tomorrow price. So it has to be like this. Let me show you first. Data, and I say close. Dot, and we have to use this shift function. And if I say -1 means the next day, -1 the next value. If I say -2, the it will be skipping 1. If I say -3, it will be skipping 2. And if I do this, so on the very first day, I am getting the next value. Can you see? It is 23.83000. I am getting it as the first value, mapped to day 6 of month 6, 29/6/2010. Now here, let's take this example. 1/7/2010. I want the next value, that is 19.20. 1/7/2010. I am getting the next value. Understood? Now we can do, if from this value, if I subtract this value, will be getting the profit. Please tell me, guys, if it is making sense. If not, then I will explain in some other way. What I want from the next day, I want to subtract the previous day. Or you can say from tomorrow, I want to subtract today, so that we can have the profit, day by day profit, right? Day by day profit we want. So what I want to create a new column. In the new column, along with today, I want to have the price of tomorrow. Like here, instead of 23.88, I want 23.83000 something. Here, instead of 21.95, I want to get the value of tomorrow, that is 19.2000, something like that. And then from tomorrow, I can, subtract this close, and we're gonna get the profit in that case, right? So if we use the shift method, and I say -1, so we are gonna get the next value, and I say, I pass this to the new variable, let's say tomorrow. Execute, And if I say data dot head, if you compare the close column and tomorrow column, here I am getting the value of tomorrow. And if you say compare this, here I am getting the value of tomorrow, that is 19.20. Yes or no? Now I can create a new column with the name of profit, and I can subtract from tomorrow. If I subtract tomorrow minus close, we're gonna get the profit. Making sense? Right? So let's say I want to create the profit column. And this profit should be what? From data tomorrow, we should subtract what? We should subtract data, and that is close. And execute. And if I show you data dot head, can you see we are making the loss of $0.05, something like that. So we if I let's say I printed 10 rows so that we can if I say 15, let's say. Yes. So you can say compare these two, like this is the tomorrow column and this is the close column. Remember that side. So here we have 16.11 and here we have 15.80. So we have got the loss of this. And here the 15 and here we are getting the 17. So we have made the profit of 1.65. So day by day, what profit we have made or what loss we have made, we have got this. Agree my point? Now you want to get this, profit month wise or year wise. How can we do that? So we can use the group by method. We can simply say data dot group by, and I want this year, and here I want the profit. And see, in profit we have in year we have months and days. So the mean value is the best method to get the values. And this is the mean profit we have made over the year. Right. So maximum we have made the $16. Like on each day, it is the average value we are getting. Right. Yes or no? Because profit we are getting, on the each day basis. So this is how we can do that. Fine. If you want the month and year both, then you can pass month column also. It is going to give like 12 by 12. What is that here? Okay, month is capital M. Sorry, guys. Can you see? So it is not printing all the values. In 2010, in the 6th month, we got this average profit. In the 7th month, we got this average profit. So almost the loss we were, getting like this, it is telling. So we are not getting all the values. So in that case, we can use the pivot table, guys. So on the index, I want the year column, and the columns that I want month, and the values, I want the profit, and my data name is data. Execute. Here we are getting the months, here we are getting the years, and here we are getting the values. So by default, it is giving the mean. So you can pass the ag func, and you can say the mean value. Fine. Yes, 2020 has only 1 month of data. That is why if you see the trend, it is showing you only for 1 month. It is not showing the trend for the next month. Can you see here? For all the years, we are getting the data trend for all the 12 months, but here for 2020, see, the red line is for 2020. We are getting the data for 1 month only. Right. So this way you can, get the analysis of the profit year and month wise. Fine. Now, if we want to calculate the total wealth, I want to calculate, guys. Total wealth means if somebody is trading on the daily basis, so someday he is getting some loss, someday he is getting some profit on the basis of negative and positive values. And if I take the cumulative value, so on the day by basis, we're gonna get the total wealth he has made. Yes or no? So if I show you, like if I say data dot and I say profit column, and we have to say come some function, it is the cumulative. Okay. Cumulative sum we have got. Fine. So cumulatively we are getting the sum. So this is $756 is the cumulative value at the end of the 20 years, 10 years of span, whatever we have, 2010 to 20 year that we have made. Fine. So I want to create a new column. Let's say data wealth. And if I show you data dot head now, so we have got the wealth. Cumulatively we are getting. If I show you tail, so the tail will be the last values we are getting. So cumulative, like 557 plus 14. Okay. So sorry, 557 plus 59, it will be 616. And you add this profit, then it will be 626. Then you add this profit and it will be 756. So day by day basis, if the value were negative, it will be deducting. So on the day by day basis, you are getting the wealth. Like if somebody is doing, on the like daily basis, he's doing something like trading. Making sense? Now, if you want to check the wealth year wise, like, in which year we are getting, what is the status of wealth over here, over the years. So then what can we do? We can say data, and we can say group by, and here we can say year, and here we can say total wealth. And here we can say the, let's say, sum of total. Okay. We are getting. So total wealth, if somebody is doing trading like this. So the mean is the, best method when we compare the whole year. So this is the average somebody has made of $521 in the 2020. Over the years, we are getting this data. Please tell me, guys, if it is making sense. And if I use the plot function now, we are getting the trend of the wealth now. Over the years. This is the trend of the wealth. If you want the values, this is the values. That's it. Fine. So let me increase the size of it again. Here it go bigger. And if I say fixed size equal to, let's say it is 8 by 6 and DPI again 100. Fine. And I say PLT dot show. Now I want to note the total wealth, how much the total wealth is. 521 is made. Okay, so how to get this total wealth? This is, and if I say This is the value, okay, that we have made finally. The last value I have, slice the last value, cumulative, wealth. So I want to print, let's say this is the, wealth W I say. So what can I say? Here I want to give the title. PLT dot title, and I can say total wealth is, and here we can say the value of W. And if I say F formatting, execute. So this is the total wealth we have made, guys. So this is, I am giving the title. So this is how we can analyze. So please tell me if it is making sense. Any doubts till now, my friends? See, when we analyze the time series data, it is also time series data because on the basis of years or months, we are, on the basis of time, we are analyzing the, so it is, line plot is the best plot in that case because it is going to show us the trend. It is showing us the trend in that case, right? So correlation is of not of much use in the analysis, but yes, it is very much important when it comes to the machine learning part. If you want you want to feed the data to any model, then this correlation is going to be very, very important. So I have just given you the idea, like on the basis of months and years, how we can analyze the stock price. So this is the stock price data of the Tesla company from 2010 to 2020. Anyone has any doubts? Yes. How to add a column, like, or how to, pass a particular function. You can ask me. How to calculate profit. So tomorrow value, how did we calculate the tomorrow value and all. So closing price, we have done it on the closing price. So if you want to analyze the volume, that is actually not required in the stock price. So we generally do the closing price, but it has given the high and lows also. So if you want to see the fluctuation from the high and low, you can use the minus and you can create a new column with the name of fluctuation. What was the fluctuation here? Any doubts? Share in the chat box, guys, please. Whether you find it helpful or not, like how to analyze in pandas. Yes, Dan. So until you do it by yourself, of course, it is not going to make much sense. Like you will get some idea when you do it by yourself. So what I'm trying to tell you, like how we can proceed, guys. So EDA is the most important part when we have any data and we want to, proceed with that. Getting my point? So how to create bar plot and all in Seaborn. So I hope you have got some idea. If you have any doubts in this, like line chart and also you can ask me. Do you want me to repeat like a recap? So first of all, we imported the libraries and after loading the data set, so we, did the, basic EDA. So in that we, check the shape of the data and the column names and what is the basic information, whether we have duplicate values or null values or not. Fine. So, and then we started with the analysis. So what we did, we converted the date column into the date time format. Earlier it was in the object column. That is the most important part, guys. And from this, we, extracted the month and year. Fine. And then we converted this date format into the index column so that we can get the trend on the basis of years directly with the help of plot function. So if you remember earlier, we were getting the counts. Now, once we convert it into the date, index column, now we are getting the trend on the basis of the years like this. Fine. Then, year wise, the what is the mean of value or the average of the closing price we are getting. We have, done that. We created a new column, and then again, we are having a look on the trend. We are getting the counts, year wise, what is the count of the closing price. Okay. We have got the average closing price. Fine. Then we had a look on the trend of the year and month wise together. What was the trend? And then, so correlation was a different, like somebody was asking how to calculate. So I did give an example how to calculate correlation. Okay. And then profitability we get. So profit, how do we calculate profit? Tomorrow minus today is the profit. And shift function is very important, guys. So -1 is the very next value. It should subtract the previous value like that. Okay. We are subtracting here. And then profit, we are getting the, with the help of pivot table, you can get the profit, average profit along with the years and months. What is the average profit somebody has made? Right. And then the total wealth that somebody has made. So profit or your cumulative sum over the period of years. Okay. So you can get the values of the wealth, total wealth has been made over the period of years. If you say the first 3 years, it had made nothing almost. But in the coming to the 4th year, 5th year, so trend was upward and up to the 2020. So, like you can say it was a huge profit. If you see the trend after some downfall here, like here we had some downfall, then here we have a big downfall, but later on it was in the upward direction. Right? So, and if we want to read the total wealth, we have made this total wealth. So that is all from my side in this, my friends. So if you have any doubts, so and you want to have this what to call data set and this Jupyter notebook, and further if you have any doubts related to data science or data analysis, whatever, so you can join the Telegram channel and you can post your queries over there. So somebody is going to there, like they're going to reply you there. Fine. Any other doubt? So could you confirm like how many of you like looking for a data scientist to be a data scientist or a data analyst? So for data scientist you can say DS, and data analyst you can say DA. So data scientist, if somebody is looking for a data scientist, so one step extra you have to do after transforming the data, you have to feed it to the machine learning algorithm. Okay, different algorithms that we have. Rest of the things remain the same for data analyst and data scientist. Fine level. So now Karishma is there. She is going to talk to you. Karishma, are you there?
Yes, sir.
Yeah. Hello, everyone.
Hello.
So yes, Dan. So you have to, like machine learning algorithm is totally a different thing. So is maybe in some other class we will have some data scientist project, and then I'll explain how to do that. Okay. With the time series data also we can do. So all this stuff is you're going to put in an algorithm, then you have to check accuracy, precision, and the error, and so many things are there. So Karishma will be talking to you now. Karishma, please carry on.
Sure, sir.